Hello everyone, welcome back to this video series on clinical SAS ADaM programming. In this video, we will see how to create ADEG dataset in a parallel arm study. So ADEG stands for ECG analysis dataset, which means the parameters which are coming out of the electrocardiogram of a subject. So let us see what will be discussed in this lesson. So in this lesson, we will see the complete programming for ADEG of a parallel arm study. So it includes creation of parameter related variables, that is param CD, param N and param derivation. It includes analysis visit windowing to derive variables like avisit N and avisit, and supporting variables for windowing, which is analysis window low, analysis window high, analysis window target day, analysis window difference from target date, and analysis windowing unit. So it also includes baseline flagging and dependent variables creation like ABLFL, base, change, percentage change. It also includes creation of category variables like evalcat1, eval CA1N, base cat1, base CA1N, change cat1 and change cat1N. It includes creation of an analysis flag, which is ANL01FL. So it is used to select one record per analysis visit per parameter and subject. And we also create another analysis flag called ANL02FL. So this is used to identify the post baseline records. And we create two shift variables, which is shift 1 and shift 2. So these are all the things that will be covered in this lesson. So let's now move to the specification for this lesson. So we have the specification here. We have been given the variable name, variable label, and the derivation logic and the comment for that derivation. So similar to the previous videos, if a variable is directly coming from the parent SDTM domain, so here in this case for ADEG, the parent dataset would be our SDTM ECG dataset, which is abbreviated as EG. So EG, if a variable is a direct copy from the source, so it is simply listed as the domain name and the variable name in that dataset. Here in this case, eg.studyid means that it is a direct copy from the SDTM EG dataset. So let's now move to the individual variables. So study ID is direct copy from study ID of EG domain, and then new subject is the same. And for subject variable, we are asked to fetch it from ADSL dataset. And then we have param variable. So it says populate as heart rate in beats per minute when param CD is equal to HR, which means before we can create our param variable, we should have our param CD already created. So param CD, it says populate with the values from eg.egtestcd, which means it's a copy from EGTestCD values. So once we have param CD available, we'll be able to derive param like this. So we'll have to assign heart rate in beats per minute for HR and PR interval for PR and QT interval when param CD is equal to QT and RR interval in milliseconds when param CD is equal to RR, QRS interval in milliseconds when param CD is equal to QRS, and when param CD is equal to INTP, the param value has to be interpretation. So we'll this has now completed the we have seen like how param value has to be assigned based on the values present in param cd variable. Now let's see how param n has to be derived. So it says populate as 1 for HR, 2 for PR, and so on till 6 for INTP. So which means we have to use the param cd variable to create param n as well. So both param and param n are dependent on param cd, which in turn is equivalent to EGTestCD. So now let's see the next variable, which is ADT. So it says populate using eg.egttc. So we know that in ADaM dates are converted to numeric format and represented in numeric format. So but in SDTM we have them as character variants. So we are asked to create ADT using the values present in EGTC variable. So and then we have the derivation logic for ADY, which is analysis relative day. So it says populate using ADSL TRT SDT and ADEG ADT. So before we can create our ADY, we need to have our ADT created. So ADT, if ADT is on or after treatment start date, then populate as the difference between ADT and TRT-STT and add 1 to the difference. So which means we'll have to subtract TRT-SDT from ADT and add 1 to that difference. Else, if ADT is before TRT-SDT, then populate as the difference between ADT and TRT-SDT, which means we just need to write the equation as ADY is equal to ADT minus TRT-SDT. And then we have the derivation logic given for a visit variable. So in some of the previous videos, we have seen that we were directly making use of the value present in uh, visit and visit num to create a visit and a visit, but in this we are seeing the case of windowing. It is a simple windowing logic here used as well, so it is not very complex. So here we are asked to populate a visit based on the values present in ADY variable of ADEG, which means in order to create a visit, so we need to have our ADY created before that step, and also ADEG.ablfl. So which means a visit has two kind of derivations. One requires ADY and the second one requires ABLFL. So we'll see that in detail. So it says populate as week 12 if ADY is in between 2 and 127. If ADY is having any value in between 2 and 127, inclusive of 2 and 127, we'll have to populate as week 12 in a visit variable on that record. Similarly, so we were asked to populate week 24 if ADY is in between 128 to 210. So if the value is anywhere in between 128 and 210, inclusive of 128 and 210, so we'll have to populate it as week 24. And then there is a third component involved here, so which is populate as baseline if ABLFL is equal to y. So the first two steps involves derivation using ADY, and the third one involves assigning the value based on the value present in ABLFLY. So we can complete the derivation of for these two steps if we have ADY in place, and in order to complete this third part, we need to have ABLFL is derived in our dataset. So we will, in the program, we will see that we'll handle these two in a single step, and we'll assign baseline in a subsequent steps after we derive ABLFLY. And then for a visit n, so we are being given the logic. So it says populate using ADEG a visit. So it says populate as 12 when a visit is equal to week 12, populate as 24 when a visit is equal to week 24, and then populate as 0 when a visit is equal to baseline. Again, so here if we see the condition that needs to be checked for week 12, so once we can make use of the same condition. We can check if ADY is in between 2 and 127 and directly create a visit is equal to week 12, and within the same step we can assign a visit n is equal to 12, because we know that a visit n and a visit shares 1-to-1 relationship, which means, so here if we see the logic is simple, straightforward. Wherever it is week 12, so we have to make it assign the value of 12 in a visit n. But we in the prior step we are being given a condition to check for 2 to 127 for a visit is equal to week 12. So when we are checking for this condition itself, we will be able to directly assign the value of 12 for a visit n as well. So we can make use of do group processing to create multiple variables. And then we have the logic for eval variable, which says populate using eg.egstresen, which means we simply have to assign the values present in egstresen to eval variable. And then we have evalc. So it says populate using egstresc. So for eval we are using standard result numeric, and for evalc we are using standard result in character format. So populate only on the records where param cd is equal to intp and leave null for all other parameters. So if we had seen, like we had 6 parameters, out of which the sixth one is INTP. So all the first 5 parameters actually take numeric results, and only the last one takes character results. So what are we doing here is we are only populating evalc on the parameter which requires character results. So however, note that in SDTM EG domain, so we would populate EGSTRESC with the value present in EGSTRESN itself in EGSTRESC for all the parameters, so including the parameters which take only numeric results. So both EGSTRESN and EGSTRESC has to be populated in SDTM EG, but however, for analysis purposes, because we will be analyzing all the parameters which contain numeric result, so we are only populating eval on those records, and for the parameters which take only character results, we are not populating the eval and only populating eval C. And then we have derivation logic for ABLFL, which is baseline record flag. So it says populate as Y on the latest record with non-missing result on or prior to treatment start date, which means so we'll have to compare our analysis date with treatment start date and also check if a record has non-missing result or not. If the multiple records meeting that criteria, we'll have to choose the latest record, and then on that record we'll have to populate it as Y. And then and the next variable we have is our ANL01FL, so which says populate as Y on the record that is closest to the target day within each analysis visit. We'll see what is the target day for each analysis visit in the next step. We have a variable called AW target. And then so within each analysis visit per subject and parameter, if there exist multiple records that are equally closest, then choose the record with latest date. So and then we have analysis flag 2, which says populate as Y on post baseline record. It says we can identify those records as if ADT greater than TRT STTs, and those records are considered as post baseline records. On all those records which meet this filter condition, we'll have to populate this flag as Y. And then we have this categorization variable, which is evalcat. So we are being asked to populate it using the values present in eval variable of ADEG on the records where eval is not null. And the derivation logic changes for different parameters. So one set is for HR, and we have one for PR and QRS, and the one for QT. So for param CD is equal to HR, we are being asked to create eval cat1, so as below. So populate as less than 50 beats per minute when eval is less than 50. And we are being asked to set it as 50 to 100 beats per minute when eval is in between 50 and 100. So inclusive of 50 and 60, which means even if the value is 50, we'll have to assign the value of 50 to 100 BPM. And then populate as greater than 100 beats per minute when eval is greater than 100. So we are categorizing the result present in eval variable. So we have seen the case for HR, and then we have been given the algorithm for the parameters PR and QRS. For both these parameters, if eval is less than 200, we are being asked to set it as less than 200 milliseconds, and if eval is greater than or equals to 200, we are being asked to set it as greater than or is equal to 200 millisecond. Similarly, for QT, we have four different levels, so which is less than 450, greater than or is equal to 450 to less than 480, and greater than or is equal to 480 to less than 500, and greater than or is equal to 500. So we will be deriving evalcat1 for different parameters based on the conditions provided. And then we have eval CA1N. So important thing to note here is that here if you see the variable name for the character version is evalcat1, but here if you see the numeric variant of it does not have a T here, so eval CA1N. So the reason is that here if you see the variable name length restriction is 8 characters, so we already had 8 characters here. Eval is 4 characters and cat1 is 4 characters. Maximum 8 characters have been used. So we'll have to reduce one letter somewhere to accommodate the numeric variant of it by specifying n at the end. So we are removing that t here and then putting it as eval ca1n. So the same is not applicable even for base cat as well. So even base cat 1 itself is 8 characters to accommodate the numeric suffix. So we are removing the letter T here. But it is not applicable for change cat 1 because for change cat 1, so if you see CHG, CAT1, it is only 7 characters. We can directly keep the n at the end without exceeding that 8 character limit for variable name in ADaM datasets. So it is change cat 1 and change cat 1n. But for eval cat 1 and base cat 1, the numeric variant is eval CA1n and base CA1n. So now that we have seen like uh, why we do not have T here in eval CA1n, let's see the derivation for uh, this one, eval CA1n. As discussed, so eval CA1n will be a numeric variant of eval cat1 and it will share one-to-one relationship with each value present in eval cat within a parameter. So for param CD is equal to HR, we have created three categories: less than 50, 50 to 100, and greater than 100. So for each of those categories, we are respectively asked to populate as 1, 2, and 3 in eval CA1n. And similarly for PR and QRS, so we created two categories: less than 200 milliseconds and greater than or is equal to 200 milliseconds. So for less than 200, so we are now asked to populate as 1 in eval CA1n and 2 for uh, greater than or is equal to 200 milliseconds. Similarly for QT, so we had created four levels. So we are creating a numeric variant with the values starting from 1 to 4 for each of those individual categories. And then we have been given the derivation for base variable. It says populate using adeg.eval on the record where adeg ABLFL is equal to y of each parameter and subject on all records of that subject and parameter. So eval on the record where ABLFL is equal to y has to be picked and populated across all rows of that subject and parameter. Similarly for base C, the logic remains the same, but instead of using the variable eval, so we are being asked to use the variable eval C. And for base cat 1, so the logic remains the same, but the input variable changes, here in this case eval cat 1. And for base CA1n, the logic remains the same, the input variable is eval CA1n. So in a single step we will be able to derive these four, because on all four of these variables the input record that had to be used is that ADEG ABLFL is equal to y. So we just need to consider eval for base, eval C for base C, eval cat 1 for base cat 1, and eval CA1n for base CA1n. And then we have the derivation logic for change variable. It says populate as the difference between adeg.eval and adeg.base on post baseline records. So we have seen that how to derive ANL0 to FL. So we were asked to set it to y on the records where ADT is greater than TRT-STT. So we just need to subtract base from eval and then assign it to change on the records where ANL0 to FL is equal to y. Now that we have our change variable available, we are creating a category for change cat variable for Qt parameter. So it is only applicable for Qt parameter. So here populate as less than or is equal to 30 milliseconds when change is less than or is equal to 30, and greater than 30 to 60 milliseconds and greater than 60 milliseconds based on the values present in change. This should have been changed here, so I'll try to correct it post this video. So I'll change it. So I'll try to correct this post making this video. And then we have change cat 1n, so which shares a one-to-one relationship with change cat. So we are being asked to set it as 1, 2, 3, and when it is when change cat 1 is less than or is equal to 30 milliseconds, greater than 30 to 60, and then greater than 60 milliseconds. And then we have percentage change variable. It says populate using ADEG change and ADEG base as change divided by base multiplied by 100 when base is not null and it is not 0. So which means base is not 0. And then we have two shift variables. The first one says populate using ADEG base C and ADEG eval C. So shift based on the result variables. So this is for param CD is equal to INTP on the records where ANL0 to FL is equal to Y. So we are populating the shift variable only on the post baseline records, and that too this shift one only on the records where param CD is equal to INTP. So it says if eval C is null, then temporarily consider it as missing, and if base C is null, then temporarily consider it as missing, and concatenate the values of base C and eval C with the word 2 in between. So we are being asked to concatenate the values of base C with the values in eval_c with a word 2 in between. So for example, if we have the value like in base C like abnormal and in post eval_c if it is normal, so we would get the structure like eval abnormal to normal. And say for example, if eval_c is missing on that particular record, so the text would appear as abnormal to missing. So that's why we are being asked to temporarily consider these two values here as missing. And then in the next step, we are being asked to create shift2 variable, but here we are creating the shift based on the categories. So here it was based on the source variables of result and baseline, but here the categorized result of eval_cat1 and base_cat1. So, and this is populated for HR, PR, QRS and QT. And again, this is being asked to populate on NL0 to FL is equal to Y records, which means they are post baseline records. Similar to what we have done here in shift 1. So we are being asked to set eval_cat1 to missing temporarily, and then also base_cat1 to temporarily missing on the records when it is missing. And then we are being asked to concatenate the values of base_cat1 and eval_cat1 with the word 2 in between. And then we have the derivation logic given for target day analysis window target, which is populate as 85 on week 12 record, and for week 24 we are being asked to set it to 169. And then we have AWT difference, so it says analysis window difference from target. So here we are being asked to populate using AW target and ADY as absolute difference between AW target and ADY, which means we need to subtract ADY from AW target, and then even if we get a negative number, we will have to convert it to positive number using, because we are being asked to populate is absolute difference. So for that we can make use of ABS function, which is absolute function of SAS, to convert negative numbers to positive numbers. And then we have AW low derivation, which says we are being asked to populate as 2. So wherever it is week 12, and then for week 24 we are being asked to set it as 128. And then for AW high, so we are being asked to set a value of 127 for week 12, and then for week 24 it is 210. And then for AWU, which is analysis window unit, so it says populate as days when a visit is not null and AWT diff is not null. And then we have some other variables, so which is EG_seek is a copy from SDTM EG, visit num and visit. And then we have some variables which are coming as copies from our ADSL dataset. So this completes the specification for our ADEG dataset. Now let's move to the programming. So here on the left hand side of my screen I have the program available, and on the right hand side I have my input dataset, all the intermediate datasets that are getting generated, and then the final dataset that is created. So here now we'll move to the program. So similar to the previous videos, all the input datasets that are required for this lesson are stored as in the form of code that creates the input datasets in a program, and I am including that SAS program here. So when that program is executed, all the datasets that are required for my for this lesson will be available for me in the work library. So let's now move to the actual programming. So here before we start seeing the program, so the input dataset for our ADEG would be, as discussed earlier when discussing the specification, is EG, and then as we need some subject level information, we are fetching that from ADSL dataset. So these two datasets are becoming input for my ADEG dataset, EG and ADSL. So I am starting with my programming here. So I am sorting the EG dataset based on the values present in study ID and useObj ID variables using sort procedure. And then I am doing the same thing with ADSL, sorting it based on the values present in study ID and useObj ID variables. And then I am merging my ADSL dataset to EG dataset to fetch TRT-STT. So we have seen that there are many variables that are required from ADSL, but in this merge I am only keeping TRT-STT because I need this variable to create ADY. So, and ADY is internally and inherently required in the derivation of our multiple other variables like a visit and other things. So I'm in this initial merge, I'm only fetching TRT-SDT. So in order to avoid having all the variables being pulled in this step itself. So in this step, I am creating a dataset called ADEG01, and I am keeping all the records for the subjects who are present in EG alone. So there can be places wherein a subject could be present in ADSL but do not have a record in EG. So in that place, if we do not keep this if A, what will we end up having is we'll have a record for those subjects as well. So we will not have meaning for such kind of subjects in EG because there will be no associated test CD with those for those subjects. So we need to make sure that we are keeping only the records for subjects who are present in EG, and in fact we could just write like if A and B as well to and use B to identify the subjects which are present in ADSL. And now let's see how to create variables which are directly dependent on some input variables which are directly coming from EG or ADSL. So here we are creating a dataset called ADEG01 using EG01 as input. So here we are creating some variables which are related to parameters. So we know that there are three variables at the max that could be derived uh, corresponding to a parameter. They are parameter code, parameter, and the numeric variant of it, which is param n. So for param CD, we were asked to directly assign the values from EG test CD variable. So I am assigning the values from EG test CD to param CD variable here. And then for param n and param, it was dependent on the value present in param CD variable. So I am creating param and param n within a single evaluation for each param CD using do group processing. So whenever param CD is equal to HR, so param is supposed to take a value of heart rate beats per minute and param n is supposed to be 1. So I am checking the condition once and then creating two variables. Similarly, I am doing this for all the other five parameters PR, QT, RR, QRS and INTP. So I have assigned the relevant param values and also the param n values using do group processing. Now that we have completed param CD, param n and param n and param variables, we'll move on to the next variables. So the next one is timing variables. So here if we see, if we are creating our ADT variable. So we were asked to create ADT variable using the values present in EGDTC. So we know that EGDTC stores the values in ISO 8601 notation in character format. So we are converting that to numeric format using input function and in format of YYMMDD 10 dot. And then we are creating our ADY variable. So for ADY variable, so there were two components involved. So we had to check whether we had to compare it with TRT SDT, ADT with TRT SDT, and then assign the value as specified. But in order to have ADY created, we need to have both ADT and TRT SDT values populated on that record. So I'm checking that case. So here, if nmis of ADT and TRT SDT is equal to 0, which means both the variables have a non-missing value, then if ADT is less than TRT SDT, so we were just asked to subtract TRT SDT from ADT. So we are doing that here. But else, otherwise, if ADT is greater than or is equal to TRT SDT, we were asked to subtract TRT SDT from ADT and then add 1 to that difference. So we are doing that here. So we have now completed ADY derivation for it. So ADT is done, ADY is done, and other timing variables are which are related to analysis visit and the windowing related variables. So when discussing the specification, we have seen that we were asked to set the value for a visit is equal to week 12 if ADY, which we have derived here, is having a value in between 2 and 127 inclusive. So that's why we are using less than or is equal to here and less than or is equal to here. So if 2 less than or is equal to ADY less than or is equal to 127, so we are assigning the value of week 12 for a visit variable. And then if a visit is equal to week 12, we were asked to set the value of 12 to a visit n, and AW target value was supposed to be 85 and AW low takes a value of 2 and AW high takes a value of 127. So I am assigning all of these variables values here within a single evaluation. So the condition that has to be met for week 12 is 2 to 127 in ADY. So and if ADY A visit is equal to week 12, so all of these values were supposed to be assigned. So I am doing that in a single step. And then similarly for week 24, so we were supposed to check if ADY is in between 128 to 210, and if that is the case, A visit takes the value of week 24. If A visit takes the value of week 24, A visitant takes the value of 24 and 169 in AW target and 128 in AW low and 210 in AW high. So this will have to evaluate while reading through the specification and understanding the specification if there are these kind of dependencies. In the case of dependencies, so we can handle it this way. We are assigning multiple variables values within the single evaluation. So when checking for the study day here in this case. And then the next variable that we are creating here is AWT diff, so which is the absolute difference between ADY and AW target. So I'm checking both of them has a non-missing value. If that is the case, so I'm subtracting ADY from AW target and then applying ABS function on it. So we'll have the negative differences also converted to positive numbers. So for example, if there is a collection on day 84 and day 86 when the target day is 85. So 85 minus 86 would result in a value of -1. So we are converting it to absolute function. So the value returned would be 1. So if the ADY is 84 and AW target is 85. 85 minus 84 is +1. So when we apply absolute function on positive numbers, it will be a positive number itself. So that will be 1 itself. So we are calculating how far is the collection day from target date. So that is that too in terms of absolute difference. And then we have AWT diff. We are assigning AWU value. So we were asked to set it to days when AWT diff not is equal to missing and A visit not is equal to missing. And then here I'm writing a format statement for ADT. So I'm applying a date9 format for this variable. And then we are deriving some other variables. So for eval variable, it is supposed to be a copy from EGST So I am assigning the EGST values to eval variable. And then for eval C, we were asked to set it to the values from EGST but only for the records where param CD is equal to INTP. So we are handling that using this conditional statement. And then we are creating our evalcat variables. Now that our eval is available and our param CD variable is also having a value, so we can create our evalcat variable and eval CA1n. So this should have been eval CA1n here. So length of evalcat1, I am assigning a value of 30. So we have seen in the specification that its derivation depends on the parameter. For HR, we were asked to assign the value of less than 50 BPM. So when eval is less than 50, and then on the record where evalcat is equal to less than 50 beats per minute, so we were asked to set the value of eval CA1 and to 1. So I'm doing that in this step itself instead of doing it separately. And similarly, I am completing the derivation for other categories of HR, which is 50 to 100. So I'm checking if eval is 50 less than or is equal to 100. If this condition is met, then we are assigning the value of 50 to 100 BPM when eval cat1, and then eval CA1n is taking a value of 2 in this record. And similarly, if eval is greater than 100, so I'm assigning this text greater than 100 BPM and 3 to eval CA1n. And similarly, I'm completing the derivation for evalcat1 and eval CA1n for other parameters PR, QRS in this section and then QT in this section. So now we have completed the derivation for variables which are directly dependent on the input variables. So let us take a quick look at our ADEG 01. So here in ADEG 01, So this TRT-SDT, we have fetched it when we were creating our EG01 dataset. Let's take a quick look at our EG01. So we merged ADSL to EG and created a dataset called EG01. So if we take a look at the dataset, we should have TRT-SDT populated for all records of the relevant subjects when there is a matching record in ADSL. And then we use this ADEG01 and created ADEG01. So after TRT SDT will now appear our newly created variables. So we had TRT SDT here and we created param CD which was equivalent to EG test CD, and then we assigned param based on the values present in param CD variable. Similarly, we assigned param n, and then we created ADT using EGDTC, and then we created ADY by comparing ADT with TRT SDT and then have the values populated. And then we created our AVisitN and AVisit by comparing ADY with the pre-specified interval bounds for our each visit. So here if we see, the analysis day is 85, and as per the derivation logic, a visit was supposed to be if ADY is anywhere in between 2 to 127, it was supposed to have week 12. So 85 is in between 2 and 127. So the A visit value is taking a value of 12. And if A visit is equal to 12, the A visit n was supposed to be 12, and then target day was supposed to be 85, and AW low was supposed to be 2, and AW high was supposed to be 127. So we have done created all the variables still here. And then next step what we have done here is created our AWT difference. So here the target day is 85 and the collection day is also on 85. So when 85 minus 85 is 0, which means it's right on the target day that collection has been made. And then we assign AWU values based on the specification condition provided, and then we assigned created eval as a copy of EGSTRESN, and then for eval C we were asked to populate it only on the parameter of interpretation, so eval C is only present on these records. And then we created evalcat1 for different parameters based on the conditions provided, and at the same time of creating evalcat1 we also created evalca1n, so based on the logic provided. So we have now completed the derivation till evalca1n, so which are directly dependent on the variables present in our SDTM EG dataset, or dependent on the variables which are derived. This is kind of like second level derivation of variables which are coming out of SDTM variables. And then we will now move to the derivation of baseline flag and dependent variables. So for baseline, so we were given the definition that we were asked to populate it on all the records where it is on the latest record on or prior to treatment start date with non-missing result. So I am using ADEG0 dataset as input and then creating a dataset called base01. In this base01 dataset, I am only keeping the records where ADT is less than or is equal to TRT-SDT, and at the same time checking whether result is not missing, either eval not is equal to missing or eval c not is equal to missing. So we will have to check for both the variables because there are some parameters which take only the eval variable and there are some parameters which take only eval c values. So we'll have to check for both eval not is equal to missing or eval c not is equal to missing. So in this base01 dataset, I will have all the records which are on or prior to treatment start date with non-missing results. So but here in this dataset what can happen is there can be one or more records for each subject and parameters which meet this condition. If that is the case, we have to choose the latest record. So how am I ensuring that latest record is picked? So here in the next step, if we see, I am picking the last record within each subject and parameter. So I am sorting the records based on each subject and parameters. So when I say last dot param cd, it says last record within each parameter within each subject. So if I choose to pick the last record within each parameters, I need to ensure that the last record will have the latest date. So that's why within each subject and parameter, I am sorting the records based on ascending date values. So when I say ascending, the latest date record would come at the end. So when I use if last.param seed in the next step, the last record with the latest date would be subsetted. So for example, if I have record uh, on 10th Jan and 11th Jan within the parameter which meet this condition. So the 11th Jan record would be the last record within the parameter. As I have ensured that the 11th Jan record is coming at the end within that parameter. So I am subsetting the latest record here in this step when creating base 02. So we will have only one record per subject and parameter in base 02. So now we know that that record will be our baseline record. So I am assigning the value of y in ABLFL. So note that this is still a subset of this record. We need to pull this information back into our parent dataset. Here in this step, we are identifying only the record which is becoming our baseline record. So we'll have to pull the information back into our parent dataset. So we are assigning the value of y to ABLFL, and as per the specification, the eval value on the record which is baseline is supposed to be our base variable value. And similarly, base C takes the value from eval C, base cat1 takes the value from eval cat1, base CA1n takes the value from eval CA1n. So in this dataset, I am keeping only the required variables. So in order to flag the ABLFL, I need to have the subject parameter, date, visit num, and the sequence variable. And in order to flag base C and other variables, all we need is u sub jd and param cd and the baseline variables. So we will use this dataset in two steps in the subsequent processing, once for populating baseline flag and once for populating base C and base cat1 and base cat1n. So in the next step, we are merging the baseline flag back onto the parent dataset using appropriate by variables. So we know that only one of the record will become baseline, and that can be identified using the variables like u sub jd, param cd, date, visit num, and sequence. So we'll link back our base 02 dataset to ADEG 01 dataset for populating ABLFL based on the values present in these variables. So in this step, when merging, so your base 02, we need to ensure that only the key variables and ABLFL is present, and the individual baseline variables which we have derived base C shouldn't be kept in this merge when we are merging for ABLFL, because this is a single time point, a single record will have ABLFL is equal to y, but base C and other records other variables will have to populate on all records of that subject and parameter. So we will do that in a next step. So when we do merge our base 02 to ADEG 01, so on that specific record which is being identified as baseline, so would have our ABLFL pulled back into this dataset. Now let's take a look at our base 01 dataset. So here are all the records which are on our prior to treatment start date with non-missing result value. From this record, so what we have done in the next step is to filter the latest record. So and then we have created our ABLFL base C, base cat1 and base CA1n. So we use this dataset in two merges, once for ABLFL and once for all the other baseline variables. So we have seen we have created ADEG01, ADEG02 to pull ABLFL dataset into our ADEG01. So now let us take a look at ADEG02. Now we should have our ABLFL value pulled into our parent dataset onto the record which is becoming baseline for each subject and parameter. So if we see, this is becoming a baseline record, and for interpretation this is becoming a baseline record. Similarly, this record is becoming baseline for some other parameter. So similarly, the baseline flag is populated on all the relevant baseline records. And now we have seen that in AVisit derivation, so we had to populate AVisit n is equal to 0 on the baseline record and AVisit is equal to baseline. So now that we have pulled our ABLFL into parent dataset, we can complete the derivation for AVisit n as well. So if ABLFL is equal to y, AVisit n is taking a value of 0 and AVisit is taking a value of baseline. So let us now take a quick look at ADEG03 and then see the AVisit values. So on the records where ABLFL is equal to y, so now we have A visit is baseline and A visit n is equal to 0. And similarly here as well, we have it populated. Let's simply try to filter for the records where ABLFL is equal to Y. So if you see on all the records, now we have ABL, this one populated, A visit n and A visit populated. So this completes our full derivation of A visit n and A visit. And in the next step, we will derive base change and percentage change variable. In order to derive change and percentage change, we need to pull our base variable into our parent dataset. So we have pulled only ABLFL in the previous step. In this step, we will be pulling our baseline variables. So we know that these base variables have meaning at subject and param CD level. So in the next step, we are merging our base 02 dataset at subject ID and param CD level. So use subject ID, param CD, a base and other base variables are also kept. Make sure that we are not keeping ABLFL Y here when we are merging at subject and param CD level, because in base 02 we had ABLFL and also these base variables. When merging for ABLFL, we need to make sure that none of the baseline variables will be kept, and when merging for base variables, we need to make sure that ABLFL is not kept, because if we keep ABLFL, so on all the records of the subject and parameters, ABLFL would be populated. So let's now see ADEG 04 and 2 and make sure that baseline variables are populated on all rows. So here if we see base C, base cat1 and base CA1N are populated. Let us take one parameter for one subject and see if base is populated correctly. So let me go ahead and filter the first subject, my CHG1001, and filter for HR parameter. So overall this subject had 4 records for heart rate parameter. So as per the definition, we were supposed to use the value in eval variable on the record where ABLFL is equal to Y and populate it as base on all records. So ABLFL is equal to Y is present on this second record. On this record, eval is 64. So which means this 64 had to be populated on all records of this subject and heart rate parameters. So we now have it populated across. So and then similarly, we were asked to populate base cat 1 from the values present in evalcat variable on the record where ABLFL is equal to Y. So it is 50 to 100 BPM. So it is populated on all the records. So similarly, we are populating base CA1N. So base C is not applicable for this parameter because base C was applicable only for INTP parameter. So let's take a quick look at INTP parameter as well and see if base C is correctly populated. So here on the record where ABLFL is equal to Y, the value in eval C is abnormal, not clinically significant. So this value should be populated on all records of that subject and INTP parameter. So it is populated correctly, abnormal, not clinically significant. So now we have completed the derivation for pulled the baseline information into our parent this dataset, parent dataset. In the next step, we'll be deriving our change, percentage change, and other variables. So we are using ADEG 04, which already has base and other baseline information available. So, and we are also creating the variable ANL02FL. So we were asked to populate ANL02 is equal to Y, ANL02FL is equal to Y on the records where ADT is greater than TRT STT. So we are assigning that, and these are all the post baseline records. So we were asked to populate the change variable and percentage change variable only on the post baseline records. So we are checking for that condition and we are creating ANL02FL is equal to Y, and then we are creating our change variable here and percentage change variable here. So when creating change variable, we are checking if eval is not is equal to missing and base not is equal to missing. And if that is the case, so we are subtracting base from eval and populating the change variable. And then for percentage change, we were asked to populate it based on the values present in change and base. So we are dividing change with base and then multiplying 100 to get the percentage change variable. As per the specification, we were asked to create percentage change only when base is not is equal to 0. So we are checking if base not is equal to 0 and then creating percentage change. So the reason why we do not calculate percentage change when base is 0 is that we cannot divide any number with 0, and SAS cannot handle divisions with zeros as such by definition, by mathematics also. So the if we divide some number with 0, we get an infinite number. So we will not percentage change, infinite percentage change does not have a meaning. So we are not creating percentage change when base is 0. And then now we have completed the derivation for change. We will be able to complete the derivation for change cat1. So for change cat1, so it was only for the parameter qt. So we are asked to set it to less than or is equal to 30 milliseconds when change is less than or is equal to 30. And then we were asked to set a value of 1 for change cat1n for when this condition is met. So we are assigning or creating two variables, change cat1 and change cat1n, by checking the condition once. And then we are checking for the condition of greater than 30 and less to 60. So 30 less than change less than or is equal to 60. So then we are assigning this text of greater than 30 hyphen 60 milliseconds and assigning the value of 2 to change cat1. And similarly, we are completing the derivation for the third category, which is greater than 60 milliseconds in change variable. And then once we have change cat completed, we are now moving on to the creation of shift variables. So as part of the shift variables, we were asked to temporarily consider the values of eval C or base C to missing. So we are creating the two temporary variables, temp eval C and temp base C, and assigning the text to missing when eval C is equal to missing. So but the shift variables, we were asked to populate it only on the post baseline record, so which could be identified with ANL0 to FL is equal to Y. So we are checking for that. And then for interpretation parameter, so we are creating if temp eval C, if eval C is missing, so we are assigning the value of missing to that temp eval C. Otherwise, we are copying the value from eval C to temp eval C. And similarly, we are doing it for base C processing and creating a temporary variable called temp base C. And then for shift to variable, we were asked to set to missing in eval cat1 and base cat1. So we are creating two variants of it, temp eval cat1 and temp base cat1. So here for and this shift to variable is applicable for the parameters where eval cat is populated. So HR, PR, QRS and QT. So we are assigning the text missing to temp eval cat1 if eval cat1 is missing, and otherwise we are assigning the value present in eval cat1 to temp eval cat1. So similar processing is done for base cat1, and we are creating this temporary variable called temp base cat1. And then we will be creating our shift1 variable. So we, instead of directly making use of val C and base C, so we are making use of this temporary variables which we have created to handle the text missing cases. And then we are concatenating the value present in eval C to the value present in base C with the word to in between. So this completes the derivation for our shift 1, and similarly we are making use of temp base cat1 and temp eval cat1 to create shift 2 variable. So let us take a quick look at ADEG 05 and see the values present in shift 1 and shift 2. So here shift 1 is created for the interpretation parameter. So let's filter. So if we see abnormal, not clinically significant to normal. So baseline was abnormal, not clinically significant, and the shift is to normal. So we have created shift 1 to handle eval C and baseline base shift, and for shift 2 it was based on eval cat 1. So here the shift here it says 50 to 100 beats per minute to 50 to 100 beats per minute. This seems to be like both eval and base have the same category. So 50 to 100 beats per minute and 50 to 100 beats per minute. So it remained in the same level. 50 to 100 beats per minute was at baseline, and the subject's HR interval still remained in that 50 to 100 beats per minute in the post baseline on this record as well. So we have completed that derivation, and then we are creating our ANL01FL. So I think we should have seen 05. Okay, so here ANL01FL is also created in ADEG05 itself instead of creating in a new dataset. So when we looked for shift 1 and shift 2, so we had seen the same dataset. So we had ANL01FL also created here, but we'll see the derivation now, how it is being created. So we were asked to set this variable ANL01FL is equal to Y as the record which is closest to the target within each analysis visit parameter and subject, and if there exists more than one record, we were asked to populate it on the latest record. So here I am making use of the condition if first dot a visit n, then ANL01FL is equal to Y. So if I am choosing that first dot approach within visit, so I need to make sure that first record is the required record. The required record is if there exists more than one record, we need to check whether that record is the closest record. So we have created this variable called AWT So to check how far is the ADY from the target A. So if it is close, the difference would be small. So within each analysis visit, so I am sorting by ascending AWT which means the record with the lowest difference from the target A would come on top. So if there exists the record with the difference of 0 and 1, so the record with 0, 1 will appear on top. And if there exist two records with 1 and 1 in AWT so we had to break the ties and use the record with the latest date as flagged. So in order to have the latest date appear on the first, so what I'm doing here is descending ADT. So which means if there exist two records which are equally far from the target day, so I am making sure that the latest record is coming on top. So I am ensuring that latest record is coming on top because here I am making use of first.avisitant. So if I am using last.avisitant here, so I should sort it in descending manner because within the, and I also need to change the way how I am sorting AWT as well. So here as I am sorting AWT to in ascending manner, so I need to make sure that the latest record is appearing on top. For that reason I am applying the keyword descending for ADT, and then on that latest record which is closest is being flagged as Y here. And then finally I am sorting the dataset based on subject ID, paramen, avisitant and ADT, and I am merging this final dataset with ADSL to pull all the other variables which are required from ADSL based on study ID and usage ID. And then finally I am keeping all the variables which are required as per the specification and assigning them to a macro variable here and using them in two places. One is on the retain statement and the second one is on keep statement. So in keep statement only these variables will be kept, but when I specified these variables in this order on the retain statement, the final dataset will have the variables appearing in the same order which is listed in the specification. So let us take a final look at the ADEG dataset which we have. So we have study ID, usage ID, param, param CD, paramen, ADT, ADY, avisitant and other variables created, and all the variables are appearing in the order as listed in the specification. So we now have completed the programming for ADEG. So this is how we can create any BDS dataset which requires shift variables, category variables, etc. Thank you for watching and keep learning.